Hey, it's us again, Eric and Bill, with the Building HVAC Science Podcast. I think you know what our goals are here. If you're not, go listen to another episode. Today we're going to talk with Russ King. He's been I won't call it a frequent guest, but he's been a repeated guest of the podcast. He just got so much to share. I really love talking to him. I think Eric does too. Today we'll be talking about ACCA Manual S. Russ gives his background again for those of you that haven't learned about the depth of experience that he has and tremendous resource he really is for our industry. We get into the intricacies of Manual S, highlighting how it's evolved into better addressing the modern challenges in HVAC design, residential HVAC design, particularly with the rise of variable speed equipment and the need for more precise dehumidification strategies. We'll discuss proper equipment sizing. That's really what Manual S is about, to ensure comfort and efficiency. Go through the process, the steps, and talk about the fact that right now the Manual S, the latest edition of it, is available as a free download. That's in the show notes. There's also a ton of other links in the show notes describing Manual S, describing the path through ACCA Approved software and how you can get from point A to point B and really take care of your customers and do a good job for them. We also end the episode talking about practical HVAC design challenges, such as thermostat placement for real, the importance of proper air distribution, and emphasizing the need for continuous learning and application of best practices. So again, take a look at the links in the show notes, especially the link to Russ's product, Russ and Connor's product called Quick Model 3D, the downloadable Manual S, the Speed Sheets, etc., etc., etc. This is a good episode. Really take heed of the conversation and what Russ has to share in terms of cracking the code, mastering HVAC design with Manual S. Good afternoon, gentlemen.
Hello. Hello. Good evening, good afternoon, and good morning to everyone.
You're going to cover it all, aren't you, Eric?
Absolutely. That's what we're here to do, is cover everything, right?
All right. Russ been on the podcast 2 or 3 times?
At least 2, yeah.
Yeah. But just in case listeners aren't familiar, could you give us a quick background on who you are and what you do?
I started doing building energy modeling and load calculations and HVAC design back in 1988, right out of college. And my degree is environmental resources engineering, of all things. And I just happened to get a job with a mechanical engineer named Marshall Hunt. And he was my mentor for many years and taught me. He was the very first ACCA certified instructor in California. And he was teaching a lot of manual JS&D classes for the utilities. And he basically wanted me to take over for that. So he trained me right away to do that. And I started teaching a long time ago. And then I ran a couple of mechanical engineering departments that specialized in residential production homes. And then I worked for a HERS training company. I trained HERS raters for a while, but my entire career has always been focused around residential energy and HVAC. And that's my passion. I really love teaching. Is probably my favorite thing of my job, is teaching. But more recently, with some of the load calc software out there that I had to teach other people how to use, got a little frustrated with it and said, there needs to be a better way. And right about that time, my son graduated from college with a degree in computer science. And his dream job was to design video games. And I said, I've got this idea for a software program. Could you help me do a little prototype so I could pitch it to some folks? And he said, sure. And that was during COVID. He was literally sitting right next to me at that time, sharing an office with me. And so I got him to do this little 3D model of a house where you could change the size of the ducts and everything. And he did such a good job with that. I was like, Connor, let's run with this. I'm not going to share this with anybody. Let's take it and run. And so I hijacked his career and convinced him to start a company with me called Coded Energy. And we've developed Quick Model 3D. It's a ACCA certified load calc and duct design software that I'm quite proud of it because my son programmed it. And I think it's a great program.
It's pretty awesome.
I have to agree. I have used that quite a bit for duct design and load calculations. And it's my favorite that I've used out there, just for building it from data in front of you.
We're talking about the ACCA. And they like saying ACCA from what I heard.
ACCA sounds like you're clearing your throat. I think
it does.
But I say ACCA all the time, and I try not to.
I know. It's just built in. It's a reflex gesture. So they have system process design. I pulled up a graphic from their website, and they have residential manuals and commercial manuals, covering from concept to load calculation to zoning, air distribution, equipment selection, duct size, and then adjust, test, and balance. A lot of information that's all made more uniform. I have this concept I want to get one of you two or both of you to validate or invalidate it, is that the ASHRAE design manuals have been streamlined for contractors through this set of system design processes. Is that more or less true?
Sort of. The way I see it is ASHRAE is kind of the math and the equations. And then what ACCA did is they took that and they packaged it along with a lot of the common assemblies and things like that and gave you, here's a whole bunch of kinds of walls and here's how you figure out your walls and windows, and packaged it to make it more user-friendly and more applied, I guess is the best way to put it. Otherwise, you'd be flipping around back and forth and going through writing your own spreadsheets with math and stuff like that. So they packaged it and put it all together to make it more user-friendly, I think, for contractors. That's my description. They may have a different description of it.
Yeah, I get it. It's the same kind of wavelength. And everybody had to write their own spreadsheet. There'd just be more of it being done than there is right now.
We'd all spend all of our time writing spreadsheets and not getting much else done.
All that silliness aside, I wanted to have you two talk about the Manual S, which is for, on the residential side, the equipment selection step of this process.
That's an especially good topic.
That is something that's fallen off your tongue very easily.
Well, I got to throw one in there once in a while.
Yeah. I invited Russ and Eric to do this because they were on the technical committee or advisory committee for the rewrite of, or the update of the manual, I should say. And Russ or Eric, do you have a background on what revision are we in right now? So we're talking about how long has this been around?
Russ, you probably have that off the tip of your tongue.
I wish I did. Actually, I was not on the development committee for the normative sections. I came in later when the normative section was pretty close to being done. I was one of the reviewers, and then I was asked to help write the user's guide as a supplement. So I wasn't in the nitty gritty part of the actual development of the normative stuff like Eric was on all the committees and stuff like that.
Yeah, so I came in as a technical advisor on that, and it's the third edition, and version 1.02 is now the most current update that's out there. This was a step in a major change for ACCA. I'll try to use their terminology that they want instead of ACCA.
Somebody's smiling right now listening to this podcast, Eric.
Wes is going, thank you, Eric. I'll get a note about that, I'm sure. Anyway, so this was a departure from what they had normally done, where they put a normative section and an informative section into the same book and then sold that book, where they put the normative section out and it is free for anybody to download. You can download a PDF of that. It's a locked PDF, but you can download it, you can view it, you can print it, you have it in front of you. And then they're doing, as Russ mentioned, a guide that's a contractor guide that is going to help guide people step by step through that process. And that's what's going to be for sale, the educational portion of that. And I think that's a really cool way to do it, because that way everybody can get the standard, they can view the standard if they want to, and then they get to buy that guide if they think they need more help with the standard.
I think they were modeling that after other codes and standards programs, because if you're going to take something in the normative section, think of it as the code language part of it. And if a state or a city or a county is going to adopt that into their code and make it part of the code, which is what ACCA certainly wants everyone to do, you can't then turn around and say, oh, well, we're going to charge you for that book. It needs to be, if it's going to be part of the code language, it needs to be public domain and it needs to be accessible. And so that's what the normative section is. And like Eric said, historically, it all came in one book, though. So in order to get the normative section, you had to also buy the informative section part of it. And with Manual S, it's interesting, and probably with Manual J and D too, and I've got them right here next to me. They've been updated and modified so many times that, frankly, it's a little difficult to find stuff in them. Like you're thumbing through and there's a whole bunch of tables, and then there's a whole bunch of appendices, and there's a whole bunch of other stuff, and to try to find stuff. And so I think they kind of wanted to start over a little bit, I think, and start from scratch. But the interesting thing is that the user's guide, the new user's guide compared to the old informative section, they're very, very different. what has actually happened is the old informative section of the current Manual S, if you were to buy it today, the book, is still super useful. There's still a lot of really good information in there that was compiled over years and years of people asking questions and then Hank Rutowski adding it into the book. So things like economic analysis and economic balance point of a heat pump, you're not going to find that in the new user's guide. The new user's guide is how to select a heat pump and equipment to meet your loads. So there's still going to be some really useful stuff in the old copy of the book. And it's going to be a challenge for ACCA to convince people to still purchase the old book. But it is very much a departure from the way they used to do stuff. And when I was writing the user's guide and obviously working with Wes and all the reviewers like Eric, we wanted it to be a super useful tool. We want it to be like, so when I need this to help me do what I want to do today. And today I have some load calcs and I want to pick a piece of equipment to meet those load calcs. How do I do that? And so it is really, really step by step. It literally takes you step by step through the process. And things like, okay, if you're doing a gas furnace, go to this section. If you're doing a heat pump, go to this section. And there's like a starting point that's almost a flow chart, not exactly a flow chart, but almost a flow chart that walks you through. And so the whole intent was to be practical and useful. And in terms of when you're writing a book, you always have to imagine your audience. Who is your audience? And it ranged from a mechanical engineer who's been doing it a long time to a student sitting in a trade school learning how to do it. And so it's broad in that sense, but both of those people have a task ahead of them. And so the user's guide is really designed to walk them through that task. So
with Manual J for load calculations, there are numerous types of software to do it. Now, for Manual S, is there software? And maybe why isn't there, or should there be?
That's an interesting question. There's no certification for software for Manual S. You can get software certified for Manual J, and you can get software certified for Manual D. But there is no certification for Manual S. But there are all the software programs, well, the main software programs that I'm familiar with have a process that walks you through the Manual S process. And what it really boils down to is the ability to read expanded data tables and do all the interpolation that's necessary to get design capacity as opposed to nominal capacity or AHRI capacities and things like that. The really fascinating part of the new Manual S is how it really expands on heat pumps for obvious reasons. In the old days, you size your heat pump to cooling, that sized the condenser, and then you looked at your heating load and your heating capacity, and you just made up the difference with strips. You just threw some electric strips on there to do it. That was the old way of sizing heat pumps, and that's how they did it for many, many years.
There's people out there who are stopping right now going, what do you mean? It's changed?
Yeah, exactly. There's a lot of reasons to do it other ways. And there's a lot of California is pushing really hard to, there's people in California, if they had their way, they would ban electric strips altogether. They're trying to come up with ways to size heat pumps for the heating load without being way oversized for the cooling load. And as we know, and what makes it so challenging is a heat pump is one piece of equipment, and it gives you pretty much a fixed cooling capacity and a fixed heating capacity. You cannot mix and match like you could with a furnace and a condenser. You could pick a furnace that had all different kinds of heating capacities and mix and match. But now you're stuck with that one piece of equipment. You have to prioritize. So are you going to prioritize cooling or are you going to prioritize heating? And you have to decide. And there's different philosophies, and it clearly depends on your climate. If you're in a super cold climate, you're going to prioritize heating. And if you're in a super hot climate, you're going to prioritize cooling and things like that. And it just depends. You've got two bars. You've got your cooling load and your heating load bars. And then you've got these other two bars that your cooling capacity and your heating capacity. And they can be all different relationships between those two things that you're trying to compare to each other. So it gets really complicated really fast. And thankful every day that I live in a dry climate. I am so happy that I live and work mostly in a dry climate. When you add humidity to the equation, man, it just gets complicated really, really, really fast. And so I was a subject matter expert on the development of the new California Energy Code, and they were trying to make it so you could size heat pumps to the heating load. And if you did that in most climate zones in California, you only exceeded the Manual S maximum target by a tiny, tiny little bit. And so they basically said, okay, we're going to allow that in California. So size to Manual S, but you can oversize the cooling if necessary and things like that. So it worked pretty well in California. But man, in other climates where you've got that humidity issue to deal with, it can be a real challenge. But then I don't think those states are as concerned about electric resistant strips as we are in California. And by the way, that all boils back to the whole grid stability thing. And if all these electric strips kicked on at the same time, would the grid be able to handle that sudden peak and things like that? So they're really trying to diversify how the electricity is used in California. So,
well, and that's one thing that can happen. And that peak grid usage with electric heat typically happens early in the morning. And if it's really low temperature outdoors, then you can get that sudden peak, especially, and I'm going to say this, especially if we're using setback thermostats. Because a setback thermostat, if it comes out of setback, it's almost always going to slam into that electric heat strip. And if you've got a whole area of houses going into electric heat all at the same time, that would be a massive load on that grid.
Another really interesting thing, since you bring that up, is now we have all these Wi-Fi thermostats. So their time is set by the same clock. And so when these houses come on, they come on at exactly the same time, within a second of each other. Hundreds and hundreds of houses all coming on at exactly the same time. Because when you set your thermostat, you don't set it for 6:47 in the morning. No, you set it for 6:30, like everybody else in your neighborhood is going to set it. Whatever. They pick these certain set times.
Got a little bit of Dr. Evil in you because these scientific disasters are really making you laugh.
Yeah. It's the reality of things. And I've been unfortunately, using a setback thermostat works well when you have an oversized gas furnace. But if you have a properly sized heat pump, do not set back. Let it run. Let it run. Let it just maintain temperature. It's more like a car going down the freeway, just coasting along, just moving along at a steady pace versus stop, go, stop, go, stop, go of that high performance race car that is just going to be drinking fuel while it's going. It might not be using any while it's not going, but when it fires up and goes, it's going to drink it down hard.
How about when you get to the situation where you're doing partial retrofit? Say you're doing like a dual fuel system and you are going to add a heat pump. Is that something covered in Manual S?
Yes, absolutely. Yeah, it was. Something else we covered in Manual S too that changed a lot in this edition was dehumidification. And Russ mentioned humidity problems there. Part of that thing that the Russ mentioned there, like we allowed heat pump sizing on heating capacity when you have a heating dominant climate, meaning you have more need for heating than you do for cooling BTU wise. Now we brought in better dehumidification guidelines to say, hey, I need to put in maybe a whole house dehumidifier because I can't cover that dehumidification load on mild days or no load where you don't have really any cooling load. You still may have a dehumidification load on that house because of the outdoor humidity. I live over on the green grass side of the country, as we call it, or the humid side.
I don't know if they specifically state this, but the priority of Manual S is comfort, is to make a house comfortable, temperature-wise and humidity-wise. The priority is not energy efficiency. The priority is not all these other environmental things, grid stability or anything like that. They're mentioned and they're talked about, and there's sections in the Manual S that allows you to address those things, but that's not a priority of Manual S. And so when they have a maximum air conditioning size based on your load, that's a comfort issue. They don't want you to put in too big of an air conditioner because it causes comfort issues. So once you realize that, you can start saying, okay, well, if they won't let me oversize in a super dry climate where we never have humidity issues, why can't I do that? Why can't I choose my own comfort level and things like that? And you can. It just depends on who's forcing you to follow Manual S. I guess if Manual S is not part of the code that you're forced to be working under, it's a guideline. It allows you to make informed decisions about certain things. But if you're in a program where they're saying, I'm going to pay you a $5,000 rebate, but you have to follow Manual S to the letter, then it gets really, really complicated. And one of the other things that I'm finding is the availability of equipment sizes. Now that all the manufacturers are going to variable speed equipment, can you find a 3.5 ton anything anymore? It's like 2, 3, 4, and 5 is your only choices these days. They don't even have half tons because it's variable speed equipment and it can range between a 2 and a 3 and between a 3 and a 4 and all that stuff. And so now what do you do if there's like a donut hole of capacity that you can't find a piece of equipment to meet the requirements of Manual S? Then you got to go look at another manufacturer, a different brand or something like that. So it's getting really complicated.
That may come back to setup on some of this equipment, because I've seen there are some pieces of equipment out there that will have a limiting switch or a limiting feature in them to where it will turn, say, that 3-ton unit maybe into a 2.5-ton unit, but it limits it. It won't allow it to go above that. But one of the challenge there becomes the manufacturers may or may not provide performance data at that limited amount. And that's something that I think the manufacturers, and rightfully so, eventually Manual S is going to have to rectify or figure out how to meet this. And I think the manufacturers are going to have to do something on their side to say, hey, we're going to have to make a change in our equipment. Probably not bring out more sizes, because I think it's, from an inventory standpoint, it's a good thing to have fewer models, but they need a way to bring those guidelines into the equipment operation side and say, okay, we're going to limit this equipment operation. I mean, there's one manufacturer out there I've heard where you can actually essentially put your manual J load numbers in there, heating, cooling, and I think maybe even the latent sensible split. I don't know for 100% because I haven't talked to anybody that's doing it yet. I need to ask that question. But then that really sets that equipment up about how it's supposed to operate for that house, which I thought was a really, really cool idea to be able to do. And it's tailoring that comfort a little bit more, because as you said, Russ, it's really about comfort. The efficiency is going to depend on other pieces of the equipment and the shell of the house, how fast it loses or gains heat to be able to operate that equipment. And that, of course, then is going to define the equipment size and everything else.
The output of Manual S, and there's a really nice page 12. I'll put in the link, the latest free version of the normative document. Nice flow chart. I love flow charts. But it says the last step is produce the project file. Do all project files look the same in your understanding?
They should have the same basic information on them, but they're not going to look visually the same because it depends on how you do it. So if you're doing it longhand on a paper or through a personal spreadsheet versus using one of the programs or one of the pieces of software that does Manual S, it's going to look differently visually.
And oftentimes these project files sit internally within a company, but sometimes they go external. Russ, do you have a feel for that?
Yeah, having been a mechanical engineer who did design for other people to install, I'm very familiar with the process of conveying your design intentions to people and being able to tell them what they have to follow and what they can have some play with. I used to get calls from installers in the field going, hey, yeah, we need you to come out here and approve this. We're making a change to your design. I'm like, well, what's the change? Oh, we want to move. There's a joist in the way. We want to move a supply register over 2 feet. Just do it. You don't have to ask me that. You don't have to call me. I don't need to visit the site for that. But then they won't call me when a 12-inch duct won't fit down in a chase and they decide to use a 10-inch duct instead. That's the kind of stuff you need to call me and say, hey, is this okay? And so when this package that you put together, this packet, it really depends. Is it a design build situation where you're the designer and the installer? And then my old boss I mentioned, he said one time, this is a horrible thing to say to somebody who's learning how to do design. He said, when you're doing a design, imagine you're sitting on a witness stand being grilled by the plaintiff's attorney who's suing you for your house not being comfortable. How do you defend your design? How do you defend what you decided to do? And so that's part of what that packet is also, is to say, the builder told me he was putting in these kind of windows, and then they turned out to put in something much cheaper. Then you're covered because you have that documented. And so that's another reason for that packet.
And the ACCA website, they have these speed sheets. Can either of you speak to those and what they are, how they're used?
I have not used one in many years, but they're basically spreadsheets to quickly walk you through the process and do the numbers for you. Like the load count speed sheet it's pretty tedious to enter the information into it, but it'll do it. It'll do it for you.
I don't remember if those speed sheets are up to the current editions.
That's a good point.
Yeah.
I don't remember because I think if I remember hearing the story correctly, and somebody will probably correct me at some later date in time, and I've often been wrong in my life, But I think that an external company or person wrote those and essentially donated them to ACCA, if I remember the story correctly. They were not an internal production of ACCA. So I don't know if they've been fully updated to the latest versions. I'd have to go look at them. But I'm like Russ, I haven't used them in so long because I've used software packages.
I occasionally hear of people using them, going, yeah, I did the speed sheet and this is the number I got. If you want to have your finger on the pulse of the HVAC industry, sign up for as many Facebook groups as you can. There are shameless people on there who are literally saying, screw doing load calcs. I do 500 square feet per ton and I'm proud of it. And there's that extreme all the way to the opposite extreme of people who will spend hours and hours and hours fine-tuning a load calculation. And
that would be a really interesting piece of evidence to see in a court case, a Facebook post saying, I do 500 square foot per ton and I'm darn proud of it.
I know. I'm just like, this is public. People can see this stuff. Do you realize people can see this stuff?
That's something we often forget is that other people can see this stuff, right?
Yes, yes.
This one is, I just downloaded it, Manual S second edition, 2014, the speed sheet. And it is a free download. So
yeah, so that's the previous version of Manual S was 2014.
If you're not doing a speed sheet, doing it on long form, whatever, how long does it take to produce one of these? And I'm sure that varies because you talked about if it's internal or external, it's going to look different.
Well, and it's going to depend on how readily available you have equipment performance data.
Assuming you have all the equipment performance data at hand, just to grind it through. Half hour, 90 minutes.
If you're doing it on a software program, you can type some numbers in pretty fast and pop one out. If you got to do it by longhand, you could probably do it in probably 30, 45 minutes, I would say.
Yeah. Bill, do you mean the loads and everything, or just once you have the loads, pick the piece of it?
Picking the equipment.
Oh, yeah. If you've used the same equipment multiple times, I just did a batch of 19 houses for a low-income program. They're all in the same city and they're all about the same size. And so they were going to use the same equipment, all these houses. So I just wrote down the 210, 310, 410, and 510. I just wrote down the sensible and latent capacity and the heating capacity of each one of those. Once I got the load for the house, I could pick it instantly because I knew what it was. But that was after figuring out the design capacities of those pieces of equipment. And it just happened to be a manufacturer that was pretty easy to do. And so I could do it in 5 or 10 minutes. But sometimes just finding the information can take you hours to get it for a particular manufacturer. But once you have the information, it's really just interpolation. You've got 4 or 5 things that the tables don't line up exactly. Like they'll have a outdoor design temperature for 95 and 100, and yours is 98. So you have to interpolate between those two. And they'll have a row for 1,000 CFM and 1,200 CFM, and you're at 1160. And so you have to interpolate for that. And it's not that hard to do.
Interpolation is defined. There is a way to do interpolation. It isn't just the way you want to interpolate.
Yeah.
It's not a guess.
It's not like interpolating conversation.
Yes, exactly. Yes.
And that's one thing that they'll state in these manuals too when you read through them is interpolation is fine. Extrapolation is not.
Not allowed.
So interpolation going between 2 known points, extrapolation is going off the chart. That doesn't work.
Yeah.
I think of it like walking a tight wire between 2 fixed points or walking out the plank.
Yeah, off the other end, yeah. You're at 2 skyscrapers, and you get to the end of the skyscraper, you just jump off, yeah. What is the airflow at 1 inch static pressure, and the charts only go up to 0.8?
Yeah,
idea.
Not good.
Yeah.
Danger, Will Robinson.
Yeah.
So we could talk about anything here. So one thing is, both of you answer separately, but what percentage designs do you think get touched by Manual S?
Oh, I'd hate to even guess at that. I'm going to go with less than 10.
I was going to say 10. Yeah, right around 10, if we're lucky.
And why do you think not? Why do you think more aren't?
The number one design strategy in the United States is trial and error. And I think if they're not getting that feedback loop and being told about their errors, I think too many homeowners are satisfied with bad systems. I think too many builders are satisfied with bad systems. And so these guys design a system and they don't hear back from it and they think it's okay. Oh, I must be doing great. I don't need to do all this math.
I've done it the same way for 20 years.
I've done it the same way for 20 years. I've only had 2 people complain. You only heard about 2 people. Or there's the ones who get sued and then they go back and they're like, oh, I can't tell you how many times I've had to help people do, I call them retroactive load calcs. where they've already designed the system and now the homeowner's not happy and now they're trying to justify the equipment that they put in this house. So they do a load calc on the house and you're like, whoa, my equipment's way too big. How do I make these loads bigger? What can I do to make these loads bigger so that they match the equipment that I guessed at to put in this house? And if they're never forced to go back and do that, they think they're doing it fine. They think everything's rosy and off they go. That's my experience. That's been my experience. Mostly new construction stuff is that they don't hear back.
And I think a lot on the retrofit side is that a contractor will walk in and just replace what's there because they assume that it was okay before or they didn't hear any complaints. And I think a lot of customers out there don't really realize what they can have for comfort, what the options are for comfort in their own house. I went into one area of service one time, and there's literally a company that in that area of service that is known to homeowners and other contractors. They call them whistle and bang because that's what their duct systems do. But everybody keeps still using this company because they've been there for so long that they must know what they're doing.
And they run TV ads.
And then everybody thinks whistling grills and banging ductwork is just, that's the way HVAC systems are supposed to operate.
That's how you know they're running. Yeah.
Yeah, exactly. And we don't want it to run very often. So we put in this really oversized piece of equipment so that it will shut off when the weather gets hot because we don't want it running all the time because that wastes energy.
Sure does.
And that's the mentality. But in reality, it costs energy to condition buildings. We can't get around that. We have to use energy to condition buildings. We just want to use the least amount of energy possible. And that means putting in a lot of times smaller equipment than what we might think it needs.
Variable speed equipment is a wonderful invention. My entire career, I was not even allowed to consider that until recently. When I ran the two big mechanical engineering departments for production home builders, if you mentioned variable speed equipment to a production home builder, they would laugh. They're like, what? Get out of here. You had to design a very comfortable house that was going to be built in any orientation with any variety of families living in it, from one single person living in a 3,000 square foot house to 12 people living in a 3,000. And you had to make all these people happy. And you figured out what it took to do that. And for me, the main thing was not oversizing the equipment. And that was a little tricky to do when you're designing for worst case orientation. And then you spin the house to the best case orientation. You had to make sure that it wasn't oversized for that too. But what I found was when the equipment is oversized, and imagine, I always tell people, be the thermostat. Imagine you're the thermostat hanging on the wall. How do you know what the temperature is in the room that's way over there? You have no idea. The only way you know is when the system turns on and air starts coming past you. You're standing with your eyes closed. All you can do is feel temperature. As soon as that system stops, all you feel is the air right around you. You have no idea what's going on over there. And so the longer the system runs, the better the thermostat is able to sense temperature in all the rooms. To me, that fixed most of the issues where I was asked to go out and evaluate somebody else's design. Like all these builders would say, Russ, we have this problem with this subdivision that you guys didn't design. We're having all these problems. Can you come help us fix this problem? And I say, send me the plans. And we do a load calc. We do a room by room load calc with the air balance targets. And then I get out there and, well, your equipment's way oversized. It's just not running long enough to sense the temperature in all the rooms. That's why the baby's room is always uncomfortable. To me, that was the most important thing, is those long run cycles. But now with variable speed equipment, you can oversize the equipment and it can throttle down and have those long run cycles. And one of the best quotes, Adam Muffich, what do you call an oversized variable speed equipment? Is the world's most expensive single speed piece of equipment because it's always going to run on low speed. But at least it can run on low speed. So that's been my big thing, is just the whole air movement and the ability of the thermostat to sense the temperature in all the rooms.
But then you get into one of those other ACCA manuals, Manual D, you have to have proper circulation, supply and return, in order to get that air in front of the thermostat.
For that to happen, yes.
And don't forget Manual T, because you got to have that throw in the room, because if you get too short of a throw, if you put in too big of a register, we'll say too big of an outlet, it may put that air closer to the thermostat when it's not conditioning the room all the way on the far side of the room. It's putting that air close to the thermostat, and then the thermostat shuts off. As a matter of fact, Billy and I worked through a problem on his house, your son, who I happen to work with quite a bit. And we worked through a problem on his house where he wasn't getting conditioning in his office. And we literally had him block off one of the ducts close to his thermostat. And guess what? Now he gets conditioning out in the far reaches of his house because the thermostat's not shutting off. It'll run longer.
Some of the biggest challenges I had in some of the houses that we did design were related to thermostats. We had a big 2-story house, 2 systems, 2-story house. And on the first floor in the middle, there was a powder room, and it was completely surrounded by conditioned space. So it had 0 load. And so in the design, I didn't put a register. I didn't put a supply register in the powder room. All it had was a toilet and a sink, but it had an exhaust fan in it. So I figured when the exhaust fan is running, it'll pull air. It'll be comfortable. The builder calls up, says, well, we got to have one in there or the homeowners will complain. I go, put a fake one in there. Just put one in the ceiling. See if they even notice. But they did. I go, fine, just run a 4-inch duct and put a little register in it. I don't care. So they did. And well, it turns out just down the hall from that powder room was where we put the thermostat. And the air was coming out of that bathroom and hitting the thermostat and causing it to shut off too soon. And so I said, you've got to close the register in that bathroom, that powder. You got to close that register off. That was affecting, it didn't have any load. The 20 or so CFM that was going into this bathroom was coming out still cold and shutting off the thermostat, which is making the rest of the first floor uncomfortable. So just stuff like that. We had a funny one time where some of these big production homes have an option where you can have a floor over the living room, or it can be open to below. So you could have like 20-foot ceilings, or they build a floor over this room and put a bedroom up there or something like that. So we had to design for both cases. What we didn't realize was we put the thermostat on the wall of the first floor. When they didn't put this floor here, there's this window way up high in the sky, and the sun would shine down and actually hit the thermostat. And so the sunbeam of this window would crawl across the wall. And as soon as it hits the thermostat, the air conditioner would turn on and not shut off for an hour. And even though the house was freezing cold because the sun was beating on this thermostat. So we modified our plan so that when it doesn't have that floor, the thermostat got pushed down the hall a little ways. So just crazy stuff like that.
So why isn't there a manual TS for thermostats?
Yeah. I like to say there's 1,000 bad places to put a thermostat, and there's no perfect place to put a thermostat. You just got to pick the least worst of the 1,000 bad places.
That is a true statement.
You have to have a good imagination as to what could happen.
Yeah.
You really have to, when you're standing there in the house, Russ has done way more new houses, like your specialties, new houses. My career's been all retrofit houses. Like I've never really gone and designed a full new house before. So I get into doing the retrofits and having to fix what was there. And you almost have to stand, for me, I have to stand in the house and look at it. And I end up visualizing how the air is going to move through that house by looking at where the registers are and the direction of everything. And I want to blow it away from that thermostat every chance I get.
But for new houses, you don't have that benefit unless you use a 3D modeling program. Hint, 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 hint.
Yeah. It's funny. We had a production home builder, a new one, moved to Las Vegas from the East Coast and built a really fancy subdivision around a golf course. And because he was from the East Coast, he insisted that every room with a closable door had a return grill in it. And every bedroom, not bathrooms, but bedrooms and anything that had a closable door had a return grill in it. And I'm like, oh, you don't need that. And he's like, no, I want it. I go, but that's adding a lot of costs. And he goes, I want it. I insist on it. I'm like, all right, or whatever. We design it. We actually had a lot of problems with those houses because of those returns. Because as soon as you put a return in a bedroom, you've basically taken that bedroom's vote away from the thermostat. That air will never go past the thermostat because it goes directly back to the unit. And so now the thermostat is sitting over here measuring all the rooms that don't have a return grill in them. And that caused some really strange issues. Plus, the city of Las Vegas, they happen to be the very first city that I ever encountered, and this was back in the late 90s, that actually required a mechanical plan in the plan set when you submitted for a permit to build a house. It had to have a full-blown, and in fact, in the city of Las Vegas, it had to be stamped by an engineer. So they were the very first ones because in Las Vegas, they're building all these retirement communities. Air conditioning is a health and safety issue, so they wanted it to work. Well, they also had a requirement that if you're building a subdivision, the sales models needed an air balance report, and all the airflows had to be plus or minus 10% from your targets. That is really hard to do when you've got returns in a bedroom. You could get it all balanced, and then you close the door and everything changes. Everything changes. All the rooms change. And you're like, all right, do we do it with the doors open or doors closed? Let's do it with the doors open because they're not saying otherwise. So we did all with all the doors open. We got it all dialed in, and then someone closes the door. It's like, whoosh, everything just went wacky.
Those doggone occupant-operated air dampers in the big duct system just always get in the way.
That's such a cool concept. If there's a supply and return in the same room, it short circuits, taking the vote away from the thermostat.
Yeah.
That's a bumper sticker. Well, it's a little bit long. Maybe 2 or 3 bumper stickers.
I can see people driving behind me squinting, going, what does that say? I don't get it.
And why is he talking about rooms voting?
I learned a lot, and I hope our listeners did, and they take a closer look at what's new there and what industry volunteers like the two of you are doing to make things better for customers and contractors. Thank you for your work on Manual S, both of you.
Thank you, Bill.
Any closing thoughts for our listeners?
I'm going to say, be willing to use the math. It works. It does. I hear a lot of people saying, oh, this math does this or does something. And what I see people forgetting is they're putting in bad inputs. And all of these math calculations in a lot of engineering formulas, manuals, they all require high quality inputs. If you're not putting in high quality inputs, there's impossible to get a high quality output out of it.
I like to tell people, don't design in a vacuum. Don't do a design. You got to test your houses. Whatever designs you can do, whatever you can possibly do to go out and test those houses after you designed it. And then share your designs with other people. Go on Facebook groups and say, hey, what do you guys think of this? Does this look right? Does this look right? Because that's how I learned, was talking to a lot of other designers. There was many years there was 2 of us, me and my boss, and that was it. And it wasn't until much later on that I started talking to other people actually doing load calcs. It was hard to find them. But there's a lot of great information out there, and share with others.
Great sentiments. Thanks again, gentlemen. Appreciate it. And listeners, we hope you got something out of this podcast too. Take care, Russ. See you, Eric. We appreciate you for listening to this full episode. In order to hear that show wrap-up notes, this outro, I mean, you had to listen to the full episode, right? You just didn't zip ahead to the outro. Or maybe you did. Well, in any case, the Building HVAC Science Podcast is a production of True Tech Tools Limited. Full disclosure, I'm a co-owner of True Tech, and the opinions voiced are those of my guests, my co-host, or myself, depending on who's speaking, of course. And if you're in the market for tools or test instruments mentioned in our podcast, take a look at what our company, True Tech Tools, TRUTECHTOOLS.com, what we have to offer. And you can use the offer code HVACBS for a nice discount. Until next time, take care of your ears so you can listen to more Building HVAC Science. Bye-bye.